Hi everyone, and welcome to this presentation on levels of measurement. Before we get into the topic for today, I just want to talk about the operationalization process that I went over in the fundamentals video. So if you recall back, we were talking about how to go from concepts to variables. So we talked about how nominal definitions are dictionary type definitions of concepts, while operational definitions are the exact procedures that are followed in measuring a concept with a variable. And so when we're going from concept to a variable or variables, this is known as the operationalization process or operationalizing. So depending on how a concept is measured, the variable will be at a certain level. But you're probably asking yourself, what does she mean by level? Well, let me explain that by going over a variable that I went over in the fundamentals video. So if we have some concept like faith, then we decide to measure it, operationalize it with a variable, then one way to do it would be the number of visits to a church, temple, or any religious institution in the past month. This could be some sort of scale based on self-reported numbers. And as we talked about back then, the 0 to 30 or 31, depending on the month we're asking, are the values of the faith variable. When we're talking about levels of measurement, we're asking, what do these values or these numbers here mean? What is the relationship between the numbers? So what does it mean to be a 0 versus a 1 versus a 25 in this case? Okay, so that's what we're interested in, the relationship between these numbers, what the numbers actually mean. So here's another example. Let's think of it in terms of something a little bit more categorical, like race or ethnicity. So if self-reported race ethnicity is my variable, and the following are the three categories that I'm going to use to measure race ethnicity, then what could these values be? What numbers would I assign? So I might say that if you are a Latino in my study, then you're a 1. If you're African American, then you're the number 2. And if you're some other race or ethnicity, you're a number 3. And of course, I could have as many categories as I want. And I would assign different numbers because in order to analyze the data at the end of the day, I can't analyze letters. I need to analyze numbers. But what is the relationship between these and among these numbers? What does it mean to be a 1, a 2, and a 3? Does 1 mean better in some way or higher in some way? Well, the answer to that question involves understanding 4 levels of measurement. So there's nominal, ordinal, interval, and ratio levels of measurement. Those are the 4 levels of measurement that a variable can be at. The reason the level of measurement is important is because how a variable is measured determines what we can do with it once we have data in terms of analysis. There are certain statistical analyses that can only be done when a variable is measured at a certain level. So when it comes to these 4 levels of measurement and analyses, the further down we go on the triangle, the bigger the base, the more sophisticated the analysis can be. So I used a triangle to represent the 4 levels because the base is much bigger than the tip of the triangle. So there's less types of analyses that we can do with nominal variables than we can do with ratio. Pretty much we can do anything with a ratio variable. And then depending on which level we're at in between nominal and interval, there's other certain analyses that can and cannot be done. So let's talk about nominal measurement. In this case, the values just name the category. So I like to think of the word nom as name, and that's how what I used to remember the name of this category, of this level of measurement. So in this case, the categories are mutually exclusive, meaning if I ask a question and it's at the nominal level of measurement, then a person can only give one answer. And there is no order implied in the values of that variable. So things that have categories like race, party affiliation, um, all the variables that we went over in terms of gender, etc., those are all nominal variables. So if we look at our self-reported race example, I've assigned a 1, a 2, and a 3, but those numbers don't mean anything. All I know when I see a 1 is that that person reported being Latino. I don't have any other piece of information. I could have just as easily taken this 1, this 2, and this 3 and assigned different numbers. I could have said anybody who's a Latino is a 15, African American is a 7, and other is 628. The number doesn't matter. All the number is going to be used for is to categorize the people in the sample according to the name of these categories. So again, it's just naming that category. Now, if somebody wanted to capture other categories, they could have as many categories as they wanted. They could have Caucasian, Asian, separated from Pacific Islander. They could have biracial, multiracial, etc. But regardless of how many categories there are, one individual person would have only the option of picking one category. That's what mutually exclusive means. Another example of a nominal variable, political ideology. That's the variable. The categories are conservative, Democrat, in between. And these numbers, again, they don't matter in terms of giving any other meaning other than that they stand in for the name of the category. So what kind of analyses can we do with nominal variables? Very little, frequencies and proportions. So here's an example. Again, this is made up data. Let's say I have a sample of 114 people and I ask them their race and ethnicity based on those three categories I mentioned previously. So basically, I can just count up how many people out of the 114 responded per category. And then I can calculate the percents. Remember, proportion and percent mean the same thing. Same with political ideology. In this case, I added the category of independent. But there's nothing much else I can do except report what percent and how many were in each category. That's the sort of the simplest level of analysis, and that's all we can do with nominal variables. Sometimes nominal variables are called categorical variables, so that's just something to keep in mind. Ordinal variables are also sometimes called categorical, but ordinal are different from nominal. Well, actually, here's something that they have in common. Again, the categories are mutually exclusive, but the difference is that now there is some sort of order implied in those values. But now those numbers actually do mean something. We have a little bit more information. We know that they are implying a certain order. But the distance between the values does not have any meaning. This is hard to sort of explain without a graphic. So or an example. So let me just go through that. So let's say I have highest educational attainment at present. That's the question I'm asking on my survey. Answers are 0, less than high school, 1, some high school, 2, a high school degree or a GED, a 3 is some college, a 4 is college degree, and 5 is more than college degree. So in this case, the categories are mutually exclusive. A person can only be in one of these 6 categories. But if we look at the numbers that stand in for those categories, we see that as the number is increasing, going from 0 to 5, education is increasing. Level of attainment of education is increasing. Okay, so we have a little bit more information than a variable at the nominal level. But when we look at going from a 0 to a 1, less than high school to some high school, that could be many different years in between. So one person this could be just a 1 year difference. For others, it could be 5 years, 3 years, right? Less than high school could be a second grade education, right? Or it could be a 10th grade education. So going from a 0 to 1, even though I've only gone up, quote, 1 point, that 1 point represents potentially different years. Same with going from, let's say, a 2 to a 3, a high school degree GED to some college. That could be very many years. It could be 1 year, or it could be 2 years or more. The variety, just the fact that there is a variety is what's key here. Same with some college to college degree, 2 years, 3 years. Whoops, sorry about that. Go back. The point here is that even though I've gone from, let's say, a 3 to a 4 is just 1 point, a 0 to a 1 is just 1 point, those 1 point differences aren't meaningful because they represent many different potential years. But with ordinal variables, we do know that there's some increase implied in this case. There's an order to the numbers. Here's another example. Let's say I ask people if they're currently in the school lunch program. So by people, I would mean children or parents being asked about their children. So 0 would mean no involvement. 1 would mean that they get a reduced lunch, say half the price. And then a 2 is free lunch. So I know that as I increase the number, involvement goes from low to high. So there's an order. So if I were to use this as a measure of poverty, for example, I would know that someone who is a 2, a child who is a 2, is more likely, and we don't know how much more likely, but is likely more impoverished than someone with no involvement. But we don't know how much. So the distance between a 0 and a 1, even though I've gone just 1 point, and the difference between a 1 and a 2, they don't really mean anything. They don't give us any other information. All we know is that there's an order, and the higher the number, the higher the involvement in the school lunch program. So with this additional piece of information in terms of order, what other analyses can we do besides frequencies and proportions? So with ordinal variables, we can do medians, we can do percentiles, and by do, I mean calculate, sorry. So what would that look like? Let's say the variable of education. We can calculate those frequencies and proportions just like with nominal variables. And I've given you the number that corresponds with each type of attainment. But we can also calculate a median. So of the 1,300 or so survey respondents, what did half of them have? What's the halfway point? And the halfway point in this case was a 4, which means that half the sample had a bachelor's degree or higher, and the other way too, that half the sample had a bachelor's degree or lower, but that's the halfway point. And then we can also calculate percentiles. So of this 1,300, a quarter were a 3, which is an associate's degree or lower. Again, the 50th percentile, which would be the median, is a 4. And at the 75th percentile, we have a 5. So that's the types of analyses that we can do with ordinal variables. I know, by the way, ordinal, the way I remember that is it's order. So there's an order to it, but that's all the information we have. Okay. Third is interval measurement in terms of the third level of measurement. And again, the categories are mutually exclusive. So you're noticing a pattern. As we go higher on our level of measurement, the variable subsumes, I don't know if that's the right word, but contains the same properties as the lower level of measurement and then adds some more information. So in this case, categories are mutually exclusive. The numbers imply an order, so there's an order implied in those values or numbers. But now the distance between values has some meaning. And when I say some, and I underline it, it's because this is a controversial point. People argue exactly what that meaning could be. So let's talk about this in terms of an example. IQ scores. The higher the number, the higher the IQ, right? You probably saw this in your human behavior and social environment textbook, or you probably went over this in that class. But here are the IQ scores in terms of for like the average population and what the points mean. So the distance between an IQ score of 80 and 90 is 10 IQ points. The distance between an IQ score of 150 and 160 is the same IQ points. Okay? So not only is there an order implied, in terms of the higher the number, the higher the IQ, we have that piece of information. But now when we're looking at going from one number to another in terms of the points, it's the same points. However, we cannot say that an IQ of 200 is twice as high as an IQ of 100. So even though the values have some meaning, which gives us that extra piece of information, it doesn't go all the way in terms of allowing us to make what are called ratios, because a high Q of 200, for example, is in the genius level, top 1%, whereas an IQ of 100 is average intelligence. So someone who is a 200 is not twice as intelligent as someone who's a 100. They're extremely more intelligent. So as I said, when we want to make statements like twice, that's a ratio. We're saying in this case 2 to 1. But we can't make statements like that because an IQ number of 0 is not the absence of intelligence. Okay? So that 0 is not what we call an absolute 0. In order for us to make statements like ratios and to do a higher level of analysis, we would need to go up one level of measurement. At this point, with interval level, the only additional piece of information we have that's different from ordinal is that the distance between numbers has some meaning. Let me give you an example that's often used in survey research. And this is not that example. Okay, sorry, I forgot. I wanted to give you one other common example. So temperature is measured by Celsius or Fahrenheit in terms of degrees. A degree is the same anywhere on the thermometer. But a 0 is not the absence of temperature. It's just very cold. So we can't make statements like 80 degrees is twice as hot as 40 degrees. That wouldn't make sense, right? So this is a more like everyday example where it kind of makes sense that, of course, going from 80 degrees to 81 degrees is going up 1 degree. And if I were to go from 65 degrees to 66 degrees, I'm going 1 degree. Those degrees are the same, right? They're calculating the same amount of temperature, 1 degree. So it's just a more everyday example to help. But now let me go to another example, which is the one I was just saying before in terms of surveys, which is Likert Scales. I'm sure all of you have seen questions that had this type of response option. Strongly disagree, disagree, neutral, agree, and strongly agree, or some variation of this. These are called Likert scales. Some argue that going from strongly disagree to disagree is going 1 unit of agreement. And it's the same according to some, unit of agreement as going from disagree to neutral, or neutral to agree, or agree to strongly disagree. All of these are one unit of agreement. So some folks who consider these types of scales as interval level of measurement will say that we can do certain analyses because these are the same unit of agreement in this case. However, others say that no, these are not at the interval level of measurement and that they're actually ordinal. Some would say that only in very few cases are there true interval levels of measurement in terms of questions. Interval variables sometimes get treated as ratio variables in terms of the analyses that we can do. So we can do frequencies and proportions, we can do medians, we can do percentiles, just like with ordinal. But some also, myself included, will calculate averages. So what would that look like? Let's say I ask people about their opinion on the death penalty. Again, Likert scale. So I can calculate the median, the halfway point. And for those of you who are paying attention to the other graph or table, excuse me, you'll notice this is the same exact data because I'm making this up and I didn't want to make up new numbers. So the numbers look exactly the same in terms of the percentile and the median and the proportions. But now I've added the average. And here's where the controversy lies in terms of whether we can calculate these types of data, or statistics, excuse me. So in this case, we know that the average is a 3.6. Well, that's a little bit more information or interesting information than the median, because the median would suggest that half the people agree and strongly agree, and then half are in the neutral disagree and strongly disagree category. So that gives us some information. But the average suggests that maybe people are a little bit leaning more towards neutral. So it's just, more information, and the more information we have, the better. Okay, ratio measurement. Categories are mutually exclusive. There's an order implied. The distance between the values has some meaning. And then, as I suggested before, there's a true 0 point. And so we can make statements like twice as, 3 times more, etc. We can calculate ratios. The 0 is actually the absence of whatever it is we're measuring. So for example, age, if I measure it in years, is a ratio level of measurement. You can be 5, you can be 54, 18, 89, etc. An infant would be a 0 because a 0 is the absence of years. I'm measuring age as the actual number of years. So someone who is 60 years old is twice as old as someone who is 30 years old. Someone who is 30 years old is 3 times as old as someone who is 10 years old. I can make statements like that because, again, we have an absolute 0, the absence of years. Let's take another example. Income, measured as wages earned in the past year. So someone can make this amount of money, someone can make this amount of dollars, etc. If I surveyed 1,000 people, I'm going to get all sorts of different numbers. But 0 is the absence of dollars. If I'm measuring it in dollars, then 0 is the absence of wages, of money. Therefore, I can make a statement like someone who makes $60,000 a year makes twice as much money as someone who makes $30,000 a year. So what kind of analyses then can we do with ratio variables? And the answer is every kind of analysis. Frequencies and proportions, medians, percentiles, averages. Now we can do standard deviations, all sorts of analyses. I'm not going to give you the table excuse me, just because it would be repetitive. And we'll talk about standard deviations later on in the semester, so I don't want to get into that right now. But just know that ratio is the highest level of measurement, so the most sophisticated analyses can be done with these variables. So I want to end this presentation by kind of giving you another way to think about the levels of measurement in terms of hierarchy. So if you think of like a staircase, and as we go up the staircase, the higher the level of measurement, then what would we start with? We would start with nominal variables because the values are only names. Right? The numbers don't really mean much. Now, with ordinal, the values can have an order. With interval, the distance becomes meaningful between the values. And then with ratio, we add the absolute zero, so that is the highest level of analysis. So we go from the lowest level of analysis to the highest level of analysis. And all that to say that when it comes to understanding levels of measurement, we're also understanding levels of analysis. So let me go over some examples, and then you can see if you can figure these levels of measurement out before I give you the answers. So here's an example of a variable. On average, I want to measure attendance to AA meetings in the past year. So someone could say once a week, twice a week, more than twice a week, but not every day of the week, or every day of the week. Okay, so on average, during a week in the past year, how often do you attend AA meetings? That would be the question, and these would be the answers, and these would be the values of those answers, or what are called response options. So what type of variable is this in terms of level of measurement? I feel like Dora the Explorer right now. So if you're having some trouble, that's okay. This is new information. So think about, what do the numbers mean? Do they mean anything? Like the higher the number, the higher the something? And then what does it mean to go from a 1 to a 2? You've gone 1 point, but how many days have you gone? Versus from a 3 to a 4, you've gone 1 point, but how many days have you gone? Well, the answer is ordinal. Why is it ordinal? Because when I go from once a week to twice a week, then I've gone 1 day, a 1 day difference between those two numbers. But when I go from more than twice a week, but not every day, to every day of the week, that could be the difference of 1 day, 2 days, 3 days. It's not the same. So that's why it's ordinal. Okay, here's another example, gender. If I measure it as male, female, transgender, 1, 2, 3, what type of variable is that? So do the numbers imply anything, any type of order? No. So the variable is nominal. The 1, 2, and 3 are only standing in for the labels, in this case, of gender. Another example, duration of services received in the past year. I asked a client, how many days of service did you receive? And they could score, meaning answer, 0 all the way to 365. If there were 365 days in the year and not 366, but you know what I'm saying. So it could go anywhere from 0 to 365. What type of variable is this in terms of level of measurement? Well, think about that 0. What does that 0 mean? If this is days, 0 is the absence of days. So this is a ratio level of measurement. Last example. Let's say I'm measuring satisfaction with the financial employment training. I'm asking the trainees about their level of satisfaction. So they're, oh yeah, sorry, I forgot what I was asking. So I'm asking them whether they think the training was satisfactory. 1 is strongly agree, 2 is agree, 3 is no opinion, 4 is disagree, and 5 is strongly disagree. So this is a Likert scale, so you probably already know it's interval. But again, it's because there's no 0 point here, right? So it's definitely not ratio. And then some would say it's ordinal, others would say interval. For our purposes, this is interval. So if I do ask you a question on the test and I give you a Likert scale, the answer is interval. Okay, here are the sources of the images. Thank you for paying attention, and this is the end. Bye.